Welcome to Learn Yourself. Today we are going to learn and understand multiple choice questions from the chapter number 1, Matter in Our Surroundings. Question number 1. Which of the following phenomena would increase on raising the temperature? Option A, diffusion, evaporation, compression of gases. Option B, evaporation, compression of gases, solubility. Option C, evaporation, diffusion, expansion of gases. Option D, evaporation, solubility, diffusion, compression of gases. So here we should know all these phenomena: diffusion, evaporation, compression of gases, then solubility and expansion of gases. So all these phenomena we should know. So what is diffusion? Diffusion is mixing of two different states matter. When two different states matters are mixing with each other, that is known as diffusion. And molecule movement, particle movement will increase when we are increasing temperature, when we are raising temperature. So this mixing will be faster when we are rising up the temperature. So diffusion will increase when we are rising up the temperature. Then evaporation. What is evaporation? Evaporation is vaporization of water or any other liquid below its boiling point. So yes, definitely when we are increasing temperature, the evaporation will also increase. Solubility. When we are adding any substance to the liquid, and if it is soluble, then that is its solubility. The amount of substance is soluble in the liquid, that is solubility. So when we are raising the temperature, solubility of substance will also increase. When we are increasing the temperature, the volume of gases will expand. It will expand its volume, but if we want to compress the gases, we have to lower down the temperature. So when we are increasing the temperature, volume of gases will expand. That means expansion of gases will happen. But contraction of gases or compression of gases will not happen. So compression of gases cannot be possible when we are raising the temperature. So diffusion, yes, diffusion will increase along with the temperature. Evaporation will also increase. Compression of gases cannot happen. Evaporation will increase, compression cannot happen, solubility will increase along with the temperature. Evaporation will increase, diffusion will increase, and expansion of gases will happen. As we are raising the temperature, particles mobility will increase, movement will increase, and its volume will expand. So expansion of gases will happen. So here evaporation will increase, solubility and diffusion will also increase, but compression of gases cannot happen. So option C is the correct option, where all the phenomena are possible with increasing of temperature. Question number 2. The gas can be liquefied under specific condition of temperature and pressure. Identify the correct set of condition for above statement. So low temperature, low pressure, high temperature, low pressure, low temperature, high pressure, high temperature, high pressure. So when we want to liquefy gaseous substances, we need a low temperature, and second, we need high pressure. Because when we are going from gaseous state to liquid state, here the mobility of the particle is very less. Particle movement is very less. Energy of the particles are less. So at low temperature, when we will reduce the temperature, particle movement will also reduce. When we are compressing them, the molecules will come together. So gaseous compound will convert into liquid state. So at low temperature and high pressure, we can liquefy the gaseous compound. Question number 3. The property of flow is unique to fluids. Which one of the following statement is correct? Only gases behave like fluids. Gases and solids behave like fluid. Gases and liquids behave like fluid. Only liquids are fluid. So we know that gases and liquids, both of them are behave like fluids because they both can flow and they have property to flow. That's why they are termed as fluid. So that's why gases and liquids behave like a fluid. So answer is C. Question number 4. During summer, water kept in an earthen pot becomes cool because of the phenomena of. Now, we know that in earthen pot there are minute holes. So water will come out of that, and because of the heat, that water will evaporate. When that water will evaporate, it will absorb the heat of the surrounding. So it will keep the surrounding cool. In turn, the earthen pot will be cool and the water remain in the earthen pot will remain cool. So the water evaporate when it comes out from the minute hole. So here evaporation phenomena is happening. So because of the evaporation of water which is coming out from the minute hole, that will keep the earthen pot cool. Question number 5. A few substances are arranged in the increasing order of force of attraction between their particles. Which one of the following represents a correct arrangement? Now, when we are arranging substance in increasing order of force of attraction, that means force of attraction will increase, and in the last substance, the attraction should be maximum. We know that in gaseous state, the attraction is minimum, then comes the liquid state, and then comes the solid. So solids have the maximum force of attraction. So any state of matter which are gaseous will have least force of attraction. Liquids are in between gaseous and solid, and solids have maximum force of attraction. So if we can see this sequence in this substance, then that would be our answer. So water, so this is liquid, then air, that is gas, and wind, again gas. So this sequence is not correct. Similarly, you have to check for the all. Air is, again we can consider in gas, sugar is solid, oil is liquid. This is not the correct sequence. The next is, this is gas, liquid and solid. So this is our correct sequence. Let us check the fourth option also. Salt is solid, juice is liquid and air is gas. So our correct answer is C, in which oxygen, water and sugar represents the gaseous state, liquid state and solid state. Question number 6. On converting 25 degrees Celsius, 38 degrees Celsius and 66 degrees Celsius to Kelvin scale, the correct sequence of temperature will be. Now here we have to convert the degrees Celsius to Kelvin. How to convert that? When any degree Celsius temperature, that temperature we are adding into 273. The resultant temperature whatever we will get will be in the Kelvin. So that is how we can convert degree Celsius into Kelvin scale. So now let us add 273 to all these three temperature. So 25 degrees Celsius plus 273 will give us 298 Kelvin. 38 degrees Celsius plus 273 will give us 311 Kelvin. 66 degrees Celsius plus 273 will give us 339 Kelvin. So we have to check that where this correct answers are from this 4 option. So we have to check for these 3 answers in our options. So 298, 311 and 339 Kelvin. So this is the correct option. Let us check the other 3 options also. 298, 300. So this is not the correct option. Then 273. This first one is the wrong. So this is not the correct option. 298, 310. So this is not the correct option. So our option A is the correct one for this question. Question number 7. Unit of pressure is. So this is a direct question. Question number 8. Phenomena of change of liquid into vapor. So liquid is changing into vapor. So that means it is changing into gaseous state. At any temperature below its boiling point. is called evaporation? This is also a direct question because this is a definition of evaporation. If they are asking that what is an evaporation, then this could be the answer. So evaporation is the phenomena which will happen below the boiling point of any particular liquid. Question number 9. Rate of evaporation increases with. So we have seen in the chapter there are some factors given into that which will tell us that if these factors will increase or decrease, it will affect the rate of evaporation. These factors are: rate of evaporation will increase with increase in temperature. When temperature will increase, the rate of evaporation will increase. Increase in surface area. When surface area will increase, the rate of evaporation will increase. When there will be decrease in humidity, rate of evaporation will increase. And last, when there will be an increase in wind speed, will lead to increase in evaporation phenomena. So these are the 4 factors, and when they are increasing or decreasing with respect to that, the rate of evaporation will also get affected. So here increases surface tension, so that is not a part of our syllabus. So no. Decreases surface tension, again that is not a part of our syllabus. Increases humidity. So humidity will affect to evaporation, but when there will be decrease in humidity, it will increase the rate of evaporation. So here this is also wrong. An increase in wind speed. Yes, when wind speed will increase, it will increase the rate of evaporation. Sometimes they may ask the opposite of this, that rate of evaporation will decrease with. Then all this parameter will become opposite. So you have to remember that and you have to prepare it accordingly. Question number 10. Pressure of air in atmosphere is called. It is known as atmospheric pressure. Question number 11. Which one of the following statement is not true? So we are looking for here a false statement out of all this statement. So first, whenever you are seeing a multiple choice question, understand the question, whether they are asking for any one of the question which is true, which is not true, which is false, or which is not false. So read the question properly and then choose the answer. So we have to find out here not true statement. That means we have to find out here false statement. Let us check one by one all the sentences. The molecules in a solid vibrate about a fixed position. So if this is a diagram of solid state, then these are the arrangement of molecules. Now there are no space or gap between the particles of the solid state. So they will vibrate at their own position. They cannot move because of there is no or negligible space. So yes, this statement is true that yes, they will vibrate about a fixed position. They cannot move. Second statement, the molecules in a liquid are arranged in a regular pattern. Now, if I'll draw a liquid states diagram, then these are the molecules of liquid. The gaps between the particles of the liquid is more compared to solid. So they are at random position. They do not follow any regular pattern because liquids do not have fixed shape. Liquids will take the shape of container. So we cannot see any regular pattern in liquid. So this statement is false or it is not true. Third statement, the molecules in a gas exerts negligibly small forces. Negligibly means we can just nullify it or we can avoid it. We can eliminate it. We cannot count it, then it is okay. Negligibly small forces on each other except during collision. So what will happen when gas particles will collide with each other? These are the gas particles. When they will collide with each other, they will exert a pressure on each other as well as on the wall of the container. But otherwise, they are very, very far from each other and they do not exert any force on each other. So we can say that they will exert negligibly small force on each other. So this statement is also true. Fourth statement, the molecules of gas occupy all the space available. For example, if this is a container and I am filling a gas whose volume, the gas's volume is very less and it can fit into a container in this much space. But gas will not remain till here. It will expand and it will spread throughout the container. So it will occupy all the space available. What all space you will give it to gas, it will occupy all the space. So yes, it is true. So statement B is not true, that is a false. So here answer we will get is option B. Question number 12. A form of matter has no fixed shape but it has a fixed volume. An example of this form of matter is. Now let us first see this comparison over here. Solid, liquid and gas. Whether they have shape, volume, whether can we compress them or not. So solids do have shapes. They have volumes but they are not compressible. Liquids do not have shape. They'll take a shape of the container but they have volume. They are little compressible. Whereas gaseous molecules or gaseous substance, they do not have shape, they do not have volume and they are highly compressible because the intermolecular space between them are very high. So that's why they are highly compressible. So based on this comparison, no fixed shape, no shape and a volume. So they are liquid. They do not have shape but they do have volumes. So here whose state is liquid will be the answer. So carbon steel, it's not a liquid. Carbon dioxide is a gaseous matter. So no, it's not a liquid. Kerosene is a liquid. So it will be a correct answer. And krypton is not a liquid. So that also won't be the answer. Question number 13. When heat is constantly supplied by a burner to boiling water, then the temperature of water during vaporization rises very slowly, rises rapidly until steam is produced, first rises and then becomes constant, does not rise at all. So let us first understand the phenomena of boiling water. So here I'm continuously supplying this heat to a water. So this temperature will go up or it will rise up until the boiling point will achieved. Once the boiling point will achieve, water will start boiling. Now once the water will start boiling, it will start vaporizing. So once this vaporization will start, all the water is converting into vapor phase. So liquid is converting into gaseous state. The liquid is absorbing all the heat energy whatever we are supplying. So once the stage of vaporization will achieved after boiling, at this stage whatever heat we are supplying to the water, water is using that heat and converting itself from liquid to gaseous state. So here at this stage, water's temperature will not rise at all because whatever heat energy we are giving, that water is using to change its state. So here state changing is happening. So heat is being used in this state change. So we will not see any change in temperature or temperature will not rise at all. So the last point is our answer, that do not rise at all. Because here they have asked during vaporization. They haven't asked when we are boiling water. They have asked that during vaporization what will happen, because so they have already achieved this vaporizing stage. They have already achieved this vaporization stage. So at this stage, the temperature will not rise at all. So whenever you have a question regarding boiling of water, understand that they are asking for which step. They are asking for this first step, that when water is achieving boiling point, or they are asking about the boiling, that when water is boiling, or they are asking about the vaporization, that when boiling will start, the vaporization will also start. So accordingly you have to answer. Question number 14, gas to liquid conversion. So when gaseous matter will convert into liquid, it is known as condensation. Question number 15, gas to solid conversion. So when gaseous matter will convert directly into solid by skipping the step of changing to the liquid, they are not changing to liquid but directly they are converting it to solid. So that is known as deposition.